Hello, YouTubers. Alright, I got a request, so your wish is my command. I'll just take you through the insides of this a little bit. Put it down. Let me put it on its little tripod so it's not so shaky. So you're not trying to look all around, right? Somebody said that. Okay, here we go. Alright, so it's just N52s. Nice. Actually, this entire thing is pretty much recycled material, except for the two most expensive things that you could possibly think about putting in a motor, which are these giant N52 magnets and this little piece of pyrolytic graphite down there, down at the bottom. And basically, this is a 1 1/4 inch diameter, I believe, and then it's a 3/4 thickness. And then I set up this coil by taking pieces of plastic and using some scissors and just cutting 1/8 inch strips and wrapping it around as guides, bunker guides or whatever. It has 4 brushes. I'll show you the schematic real quick. It's got this 7-pound flywheel, like I was saying. It's heavy cast aluminum. It has stainless steel washers on the flywheel with some stainless steel nuts, so as to reduce like lens drag or iron ferritic material, so the coils don't interact with it too much. And then I have actual just normal fender washers here that are magnetic. And that's okay because they're in the magnetic center. There has a rotor. And then this is a piece of 3/8 inch threaded rod. It's your standard steel threaded rod. And then you got your magnetic bearings. And there's a brush there, and actually there's a little brush position down at the bottom. So technically this has the potential of 5 brushes now currently. Oh, zoom! You. How dare you? There we go. Sorry about that. Okay, and then that's pretty much some more detail. I think Sons of Tesla was asking me to show the innards a little bit, so that's the innards. And the brushes really kind of hold up the frictionless bearing. It's almost worthless to have this magnetic frictionless bearing in a way with these brushes so tight to it. So I got to kind of adjust that a little bit. I think it's the brushes that's doing it, unless something else is kind of impeding it, is in the way. I don't know. I have to look into it. But I was using this as kind of I was hoping to, up the voltage a little bit, as like a transformer, but I think it's actually doing me more harm than good. I was thinking either it would increase the magnetic flux of the actual interior part, or maybe add a little current to the back end and induce a little current, but it is done really neither. Instead, it's just impeding it. If I run it backwards, it seems like it's stronger, but I didn't set up the motor to run that way. It'll actually script the brushes. I could switch the whole thing around or rewind that the proper way, which I might end up doing, or I'll just take it off, because it really should run through the entire rod, through the magnetic core, is the way that Joseph Newman has his setup, and that's kind of what I modeled it off of, right? Kind of took his ideas, so I might as well do it the right way. Also, that's the Homo-polar motor type of scenario, so I think I will go about that route. And I have the schematic here for it. I got it pretty much hardwired up, except, like I said, I was having some trouble with it. And then I think I've already shown some of these schematics. Here's the commutator, which is upside down. I only have 24 flashing points, or contacts, I should say, 24 contacts, and only 6 firing contacts. And my commutator is 3/16 for each of the firing points, which would make it 6/16 as the actual fire. and then the blank would be 3/16, and then the short is 3/16 as well. So I don't have it exactly to that specifications. Here's kind of this rough schematic I drew up real quick. And yeah, you can freeze that puppy if you want, but my suggestion would be don't do 2 slip rings. I have a copper flashing kind of as a slip ring with a brush to it, and I would suggest not doing that because it just it needs to run through the core here. And also I think I'm gonna get rid of these brushes and actually just wrap some copper wire around there. It'll probably hold to it a little better. The brushes, you know, leaving some carbon residue and just not quite doing what I was hoping for, and staying close to it. It may look ugly, but I mean, the thing is, it's all recycled material. It's not like it looks like the prettiest thing in the world. Maybe one day I'll be able to get some, you know, machine stuff, some CNC'd or laser cuts, acrylic and all that stuff, rather than all the hand tool building stuff. But that day is not today. And then here's the commutator with a little bit of hot glue on it. Just another example of it, and basically it has a split at the 180. So as this turns, you see this is soldered into 1/2 of it just on the firings, and I set it up in series. This one's set up in parallel, right, the way they have it set up here, but I set mine up in series. It shouldn't really make a difference, but who knows, maybe it does. And if somebody has some insight on that, I'm more than happy to hear words of wisdom. So you can see on either side it has a wire coming out from the firings, and then of course you have it shorting to each other, and then you have blanks in between. So there's a little better description. Hopefully the last description I really need to make, unless I do some crazy modification to it or find out it's working really well, and I'll let you guys know if that happens. But as far as efficiency goes, it's just you know, moving a really heavy weight with very low current. That was kind of the idea behind it, and it worked pretty well. So I'm actually quite satisfied with how it worked. And then of course, after I get all the use I can out of it, I'll take her apart, and I don't know, I might end up using this housing as the newest Bedini motor. Me and a buddy have been talking about getting a Bedini motor in a vacuum to see and filling it with maybe inert gas like helium or something, and see if we can get it to spin with extremely low friction. And then working on a even greater magnetic bearing design with the pyrolytic graphite, kind of give it levitation effects. And one last thing. Oh, Sons of Tesla was talking about the magnetic bearing with like a piece of iron in between, and that's a pretty good idea. I'll probably explore that. And this, in a way, kind of has that. Let me get a down shot view of this so you can kind of see. You know, it has this wobble a bit, you know, but it's not too bad. The brush down there is kind of stopping it. I don't know if you can see that brush, kind of stopping it, but you know, it spins pretty well. Of course, it looks so lovely with all that beautiful hot glue on it, and yeah, it spins pretty well. Not too bad. Just has a lot of friction to it for some reason. I gotta see what's going on with the brushes. I think it's the brushes. I'll probably just add some, like I said, a little copper wiring, and also take off that winding, solenoid winding, because it's not helping me. And that's pretty much all I got. I better check these. Right now I'm charging up some super caps, and I'm gonna see if I can. Yeah, it's getting there. Should be running about 12.2 volts in series. You could probably overcharge just a touch, but just off this little makeshift power source, and she flies. I don't know if you can hear that. Yeah, for such a little simple Bedini setup, it sure works pretty good, pretty fast, and decent amount of torque too. Not too bad. And then a little homemade heatsink. It's kind of retro 1950s.
I think it's cute. Anyways, I hope you guys like that.